Okay, so we have our ball coming in at 45. We have our batter hitting it in the opposite direction at 50. We're going to look for the change of momentum. Remember, change of momentum is P final minus P initial. Okay, and one thing you do have to think about is velocity is a vector. Momentum is also a vector. Okay, so that is important in this problem, is that you do have to think about the direction. So for example, this guy will say is going to the left, so we'll just say it's going to be a negative 45. This one's going to the right, so we're going to say, all right, that's a positive 50. So when you do your change here, so for example, this would be MV final minus MV initial. Our mass was 0.2. Our final was 50. So that gives us 10. So 10 kilogram meters per second. And then the final is 0.2 times negative 45. So that gives us negative negative, right? Negative negative 9. So what's the actual change? 19. Okay, so you have to be careful. I know a lot of you got 1. Okay, you forgot the direction. But think about it conceptually here. Those of you that got 1, basically what you're saying is the ball's going 45, and then you're going to tap it up to 50. So it's going 45, you're going to get it to go a little bit faster up to 50, right? That's very different from it going 45 this way, from you slowing the ball down, changing its direction, and then speeding it up to 50. That's a very different situation, and that would require a lot more impulse to get it to change direction and speed up in the opposite way than to just get it to go a little bit faster from 45 up to 50. So that's kind of the meaning here, and why you have to subtract or have a negative value here. Okay. All right. So after that, then the rest should be fairly easy. How do we get J? It's the same, right? So it's the same. Well, remember I told you the units for J. What did we say the units for J were? Newton seconds. So how is that possible that Newton seconds and this is kilogram meters per second?
Newton meters over second squared.
Right. So what is a Newton? Kilogram mass times acceleration, meter per second squared times seconds, and you get the same thing. So they are the same. So units for impulse can be either this or this. Same thing with momentum. You could write momentum as Newton seconds also. That would also be correct. Okay, and then lastly, finding the force. So J just equals Ft. So 19 equals F times 0.05. What's our F? 380.